Hey there, Jack here from EinScan 3D. This video is about reverse engineering this lathe gear cover from a 3D scan. The part was pretty badly damaged, it was broken in half and bent pretty out of shape. And the goal was to recreate the original geometry accurately enough that a replacement could be manufactured that it bolts straight back into the lathe. Let's have a look at the footage. So I started by scanning both the damaged part and the lathe itself. This gave me two things, a rough geometry of the broken component and the exact mounting locations on the lathe, so I could verify that the finished CAD model was still bolted straight back on. I then brought the scan into SolidWorks and started sketching out the main shape. I'm using a plugin called Xtract 3D, which makes working with scan data much easier inside SolidWorks. By generating these red section lines, they basically show you the shape of the scan on any plane, and you use them as guides basically to recreate the original geometry. It's always important to fully define your sketches. Aside from just being good practice, reverse engineering is really about determining the original design intent, and production parts are almost never made with just random dimensions. So the goal is to work backwards to figure out what those dimensions were meant to be, and part of that is putting dimensions in and defining them. This part was obviously damaged, and whatever impact caused it to break in half also caused it to bend quite a bit. So I'm just trying to approximate the original shape as best as I can. Scanning the lathe itself allowed me to match the hole locations up perfectly, so by the end we'll be able to verify that the mounting locations are correct, and we'll also have corrected the damage in the part. Rather than modeling this in one component, I'm building it up from a number of separate bodies and merging them towards the end. It's sort of like a hybrid Boolean modeling approach. I find this is one of the easiest ways to model cast components, especially because it gives you a lot of flexibility when you're trimming and combining awkward shapes. From here on, it's mostly a matter of just refining each feature and gradually bringing all the bodies together into a finished model. For this job, the client was actually the machine shop that was going to manufacture the part. Because I wasn't sure how they wanted to approach the work holding and tool selection for actually making this part, I decided to leave all of the fillets off the finished model. On a 3-axis mill, the tooling and machining order can often dictate what fillets are practical to actually machine. So I figured it would be a better thing to just leave all those decisions up to the manufacturer, who was also the client in this case. And there we go. After correcting all the damage, the cover bolted straight into the lathe and all the mounting holes lined up exactly, which is always satisfying to see. So I hope you enjoyed that. If you've got any questions or comments, please leave them down below. If you're in Perth, WA, need mechanical design or 3D scanning work, please reach out. Rescan 3D. I've been Jack. I hope you've enjoyed it. Cheers.